Welcome to our lesson on double replacement reactions. This is one of the most important types of chemical reactions you'll encounter in chemistry. In a double replacement reaction, two compounds swap partners to form two new compounds. Think of it like a dance where partners exchange positions. By the end of this video, you'll understand how these reactions work and be able to predict their products. Every double replacement reaction follows the same general pattern. A B plus CD yields a D plus CB. Let me break this down. We start with two compounds. A B and CD. The part, which is usually a positive ion or cation, swaps places with the C part. Meanwhile, the B part, typically a negative ion or anion, exchanges with the D part. The result is two completely new compounds, a D and CB. Double replacement reactions have two defining characteristics. First, they involve an exchange of partners. The positive and negative ions literally swap between the two starting compounds. Second, these reactions always begin with two ionic compounds as reactants. You need both compounds present from the start for the exchange to occur. Without two ionic compounds, you cannot have a double replacement reaction. Let's look at a classic example. Silver nitrate reacts with sodium chloride to produce silver chloride and sodium nitrate. This is a precipitation reaction. When we mix these two clear solutions, something dramatic happens. The silver ion from silver nitrate combines with the chloride ion from sodium chloride to form silver chloride, which is insoluble. It precipitates out as a white solid that you can actually see forming in the solution. Double replacement reactions come in three main types. Precipitation reactions form an insoluble solid that falls out of solution. Neutralization reactions occur when an acid meets a base, producing salt and water. Gas formation reactions produce a gaseous product that bubbles out of the mixture. Each type has a driving force that pushes the reaction forward, making it proceed to completion. Here's a neutralization example. Hydrochloric acid plus sodium hydroxide yields sodium chloride plus water. This follows the classic acid plus base pattern. The hydrogen ion from the acid combines with the hydroxide ion from the base to form water molecules. Meanwhile, the sodium and chloride ions pair up to form sodium chloride, which is common table salt. This is one of the most important types of double replacement reactions in chemistry. Now let's examine a gas formation reaction. Sodium carbonate reacts with hydrochloric acid to produce sodium chloride, water, and carbon dioxide gas. When you mix these reactants, you'll see bubbles forming immediately. The carbonate ion reacts with the acid to release carbon dioxide gas, which escapes from the solution. This is the same gas that makes soda fizzy and the same reaction that occurs when you mix baking soda with vinegar. To predict whether a double replacement reaction will occur, you need to know two important rules. First, use solubility rules to determine if any products will form a precipitate. If a product is insoluble, it will drive the reaction forward. Second, check for a driving force. The reaction needs to produce either a precipitate, a gas, or water. Without one of these driving forces, the reaction may not proceed at all. Balancing double replacement equations involves three systematic steps. First, write the skeleton equation with the correct products by swapping the ions. Second, balance each element one at a time, adjusting coefficients as needed. Third, double-check that all atoms are equal on both sides of the equation. Remember, you can only change coefficients, never the subscripts within chemical formulas. Take your time with each step to ensure accuracy. Let's review the key takeaway from today's lesson. The general formula for double replacement reactions is a B plus CD yields a D plus CB. Remember, ions swap partners to create new compounds. Look for the driving forces: precipitation, gas formation, or water formation. These reactions are everywhere in chemistry, from neutralizing acids to creating precipitates in qualitative analysis. Master this pattern, and you'll be able to predict and balance countless chemical reactions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.